So I'll get that set up now in a second. We'll take a better, closer look at it. So the outer bearing is completely gone from the looks of it. Yeah. The inside bearing is still in place. The outer bearing appears if it's simply slipped off the retaining bolt / axle, and I assume it's on the ground somewhere out there. The furling mechanism seems to have come through intact. Doesn't appear to be any problems with that. So that's good news. So 3 blades have come loose. They were welded on right here. Now it's possible they might have came loose first, and the vibration might have caused the other problems. Difficult to say because it happened when it was dark out and I wasn't observing it. Either way, it's kind of a total failure. Right now my best guess is that the first to fail would have been the main rotor bearings. They're pretty dubious looking in the first place, and that would have introduced major vibrations which might have caused the blades to separate, and the vibration from all of that caused the yaw bearing, which is just a hole in the top structure of the tower, to loosen up and fail. My best guess on it. So this is one of the blades. You can see where it's separated from the inner ring of the rotor, and broke presumably through vibration and fatigue over the last few hours. The blades are also secured by a small weld up on the outer wire ring. So the combination of all that caused them to, the other 3 blades to separate. So I just found these parts of the main bearing on the ground out there below the tower, so I kind of think that was the first part to fail. They were questionable bearings, so I think that might have been the start of the sequence. So clearly the bearings are useless, but I will attempt to find replacement bearings to continue with the experiment, but I will have to get something of better quality, of course. There's the outer ring of the bearing. That's the only part that stayed in place for this end of the rotor hub. The other one is still down there, but in dubious condition. So my aim in part is to try to find some alternative bearings, hopefully with half decent quality. So the inner part ring of the outer bearing was on the bolt, so that's pretty well useless, although it could make a nice deep washer for the next bearing assembly. Here's one of the old bearings. That's in pretty bad shape. It's about to come apart like the front bearing. This was the back one. This part of the front bearing right here. The other parts are on the ground or wherever. So it turns out the size of the bearing is quite common. I was able to pick up a couple of replacement bearings at the local Purchase auto store, just $2.50 each, so I was lucky to see that. I'll tap this in. There's one there. I have to redo this blade right here. My weld didn't work out that good. I'm going to work on that later, and I'll try to get the blade rebalanced as well. So here's a second bearing. I'll get that tapped in place. There we go. So I think these they're sealed bearings, $2.50 each. The original bearings are very poor, very slack, and I didn't have a lot of faith in them in the beginning, so I'm hoping we'll get better results now with the later one. So I'll be using the same bolt that I used previously, 3/8 inch bolt. This bolt doesn't fit perfectly. It's a little bit smaller than the inside dimension of the bearing, but it's equivalent to what was in the original package in terms of fit, so we'll see how that works out in the final running of the machine. With the bearing failures and the broken blade sections, the good news is that the furling mechanism survived without any problems. So that'll be incorporated into the repaired windmill. Everything good here, no problems. So I'm going to try some of this JB Weld epoxy to help me get these blades re-established. I made a couple of welds there, but the metal's so thin that I think I would need a very experienced welder to do it properly, so I'm going to try this stuff anyway. So I have the rotor blades patched up a bit with some epoxy JB Weld. Kind of messy looking, but I'll probably add some more, try to reinforce the blades for the next try. So the top cap of the tower, I just removed it, see what can be done about it. The yaw bearings, nothing more than probably a 1 inch deep hole in this, I think it's cast aluminum structure here, and the turbine assembly itself flops in it. So I need a better bearing system, something to support the shaft itself. So this is the yaw shaft, let's say, and it goes into here like that, but there's a fair bit of play in it, and I think that play increased when we had the failure initially, so I need to have some additional support here. So I'm going to fill this end cap up with automotive type body filler, the kind that's suitable for drilling and tapping. And when I get that filled up, I'll drill a new hole for the yaw shaft or rod, and I'll drill and tap holes for the screws that attach the cap to the tower. So I have a 3/8 inch diameter dowel with a bit of tape around it inserted through the original hole. The hole that required for the yaw shaft is 10 millimeters, which is a little bit larger than 3/8 of an inch. So I'm going to use this as a drill guide, and when I drill the hole finally after the body filler is in here, this will be an excellent reference for the drill to get through for the new bearing hole. There, I think that should do it. I'll let that harden up a bit, and then I'll make impressions with the skewer here to guide me in drilling the holes for tapping for the screws a little bit later on. So it looks like it should work good. Drill and tap right here, so that's the next step in the process here. So the tap so I'll put a 1032 screw in there, temporarily at least, and then we'll do a hole on the opposite side. So I'll use either lock washers here or a locking compound, Loctite type stuff. The paint right here was scraped off this platform when the main bearings failed and the blades scraped against this for a few hours. Trying to trim off some of the rough epoxy on the blades here just to dress it up a little bit. Probably won't make much difference from an operational aerodynamic type of point of view, but might make it look a little bit. So the rotor is balanced at the moment. I just reinstalled the tower out on the lawn. Now I want to put on the rotor blades, some segments of reflective tape. It's kind of handy to track the movement of the turbine during the evenings and overnight. So while I'm doing this, of course, I have to watch for the balance of the rotor, because something as small as a small piece of tape can upset the balance there. That's not too bad of a balance. I'm going to use the white sections of the tape on the back of the rotor, and that way I'll be able to tell which direction is pointing. Yeah, a couple more pieces probably would be good there. It's not as nice as the original red paint that was on the outside of each blade, but I lost that paint scheme when I had to rebuild the blades after they broke off. So there's lots of JB weld on there, and actually a fair bit of galvanizing type paint on there as well. So the overspeed mechanism survived the initial failure of the windmill. All this came out without a problem. The trouble is we never got a chance to see if it's working okay in high winds, because the bearings on the rotor failed. I located a 10mm bolt, hex bolt, and this is a stainless steel one. And my goal is just to tighten this up without putting any load whatsoever in a thrust direction on the bearings. So that looks about right there. Looks good. So I think we're ready to reinstall the turbine on the tower. We have some good winds coming up over the next couple of days, so I want to get it installed and check it out. Let's double check here. There's a small bit of sloppiness there, but I'm hesitant to tighten any more at this stage to reduce the chances of overloading those bearings in that direction. So, just in review, the way this turbine is supposed to work, hasn't been tested yet, is when the winds increase to a point where we want to control the speed of the rotor, the tail will stay in alignment with the wind will hold that in place, and then the load on the rotor will overcome the spring that's in place right there. The rotor will fold like that. This will reduce the exposure of the rotor to the wind, and the turbine rotation will slow down. That's the theory. This idea has been in use for 150 years in American water pumping farm type wind turbines. This is just a slightly different mechanical mechanism based upon that idea. I'm thinking now that this might occur possibly 50 kilometers an hour, 30 miles an hour or so. And we'll have to wait and see about that. Since I had to repair the blade, I'm noticing here that a couple of the blades come pretty close to the spring eye bolt here as they rotate. I might bend a couple of them slightly to reduce the chances of contact. So I'm going to inject a blob of this anti-seize lubricant in the yaw bearing hole that's already part of the tower, and when I get that done I'll be ready to put the turbine in place. So the windmill is reinstalled. I have 2-foot rebar pieces securing the legs. I also have 4 guy ropes securing the tower there, keeping it reasonably vertical. We're expecting some high winds next few days, so we'll get a chance to test the overspeed control mechanism. There's a fair wobble in the blade, but that's the way it was put together. I have a pretty good static balance of the blade, so I'm hoping that the vibration will be minimal. So I have some Christmas tree light on the tower. I'll check it out at night, see what they look like, and if necessary we'll add some more. So the axle or bolt through the rotor bearings and the mounting point here was a little bit sloppy, so I've got the windmill in. I added a flat washer right here, and I tightened the nut up a bit more than earlier. I still have free movement of the blade, and I think that should work better. There's a fair bit of sloppiness overall there because you have the hinge itself, and combine that with the sloppiness that was right here, it kind of added up a fair bit. For this next experiment today, I've inserted a piece of negative film in the spring. This is just to give me an indication when I'm not watching to see if the spring is extended due to the hinging of the rotor with respect to the tail or furling. Expecting some high winds today, so I'm looking forward to a good test.